Hey up, year 7. Okay, just another little quick update on how you might want to look at solving your equations. Hopefully these have gone okay for you. I just want to kick it up a gear because some people are at the point where they're thinking, well, I don't really need the area models. I can kind of see what I need to do in each problem straight away. And even if you haven't noticed what you need to do in each problem straight away, this is me going to take you to that next step where maybe you don't need to be using this. So what some people are noticing is when you've got a problem like 2b plus 4 equals 14, you ended up doing 14, take 4, which is opposite of add, and then after that, whatever you got, you, instead of doing times 2, which it says here, you did the opposite of that, you did divide 2. So in actual fact, you're kind of working backwards from 14 and doing the opposite. So you go in this opposite direction, and when you're working in reverse, you're doing things in reverse, almost like BIDMAS in reverse, where normally we do things in that order, but when we're solving, we tend to start at the bottom and work up. You know, we adjust the adds and takes first, and then we do divides and multiplies, and we'll do these things at the top last. Okay, so it's quite interesting, and actually, because we're working backwards, everything switches signs. So we get these inverse operations, these inverse signs, which is pretty handy to have straight away. So I'm just going to put these inverse signs here. Inverse ops to remind us what we're doing, inverse operations, an add and a subtractor inverse to each other, okay? And you can, when we're solving, we're switching them back and forth, we're doing the opposite thing to normal. And a multiply and a divider inverse operations. If you get tricky ones, you might get a squared. Well, the opposite, the inverse of a squared is a square root. Okay, so I'm just going to pop around that. They're really handy to have on your page when you're doing solving, just to remind you what you need to try and do. Cool, so let's try this one here. Let's just show this as an inverse operation. Let's go 2b plus 4 equals 14. But we know, actually, we're going to get b on its own. We're going to find out what b is, and to do that, we need to unpick or work backwards. We're going to do 14. Not add 4, but going backwards 14. Oh, take 4. So I'm going to write take 4. I'm going to get 10 there. Now that 2b, that's gone. Okay, that plus 4, we reversed it, take 4 gone. We're left with 2 b's. Oh, close to solving it, close to finding out what b is. And we're going to keep working backwards. Instead of that's a times 2, we're going to do a divide 2 to solve it. So we're left with b equals 10 divided 2. 5. Happy days. Cool. Try this one here. We had 3c plus 2 equals 20. Just showing it as a reverse operation. 20 going backwards. Instead of plus 2, we're going to do the opposite of plus. The inverse of plus is take 20, take 2. That's going to give us 18. Now the plus 2 has been reversed. It's gone. I'm left with 3 c's or 18. Again, that's a times 3 there. We're going to reverse it by doing divide 3 because times inverse is divide. That's going to go 18 divided 3 gives us 6. C equals 6. Beautiful. Okay, and it's really important to really just at least communicate with anybody that's watching your work, i.e. somebody marking your work, particularly if you're doing exams. This is my thinking. This is what I'm doing. That's enough right there to show you know what you're doing. Right, well, let's just kick that along and go, actually, why don't we try that reversing on these little numbers here. 2n plus 1 equals 9. I'm not going to draw the bar model. I'm just going to start by reversing everything. All right, so I might put my BIDMAS here and know that when I'm solving, I'm doing that backwards. Might put some inverse operations nearby. So let's just go plus take times divide square root. That's pretty much all the ones I need to worry about. Right, let's do this then. 9 Working backwards, inverse of plus 1 is take 1. So 9 take 1 equals 8. 2 ends are left. Opposite of times by 2 is divide by 2. 8 divided 2 is 4, so an n is 4. Because as you work backwards and reverse these things, you're effectively removing them. So the plus 1 was removed when we did a take 1. The times 2 was removed when we divide 2, and we're left with just n equals, which is exactly what we want. Next one. We've got 6x minus 4 equals 14. Let's work backwards. 14, opposite of take 4, plus 4. 14 added 4 is 18. That minus 4 has been effectively removed. 6x is all we have left. That's times by 6, so let's do the inverse of that, divide by 6. 18 divided 6 is 3. Now, if you're ever unsure, you can plug that back in. 3 goes there. 6 3s are 18. 18 take 4 equals 14. Tick. Got it right. Next one. This one sometimes throws people, so let's have a look. We're going to do 4. Working backwards. 4. Opposite of take is add. Inverse of take 5 is add 5. 4 add 5 equals 9. Awesome. So I'm down to x over 2, or x divide 2 equals 9. Okay, well, let's do the inverse of divide 2, which we know is times 2. Inverse of divide is times. 9 times 2 is 18. X is 18. All right, last little one. We go to trying out, here we go. Let's try for something like, 3n plus 8 equals 2. Now, alarm bells for some people probably ringing straight away thinking, hang on, if I add 8 to anything, getting 2 seems a little bit odd. Unless, of course, we know that there are numbers that are quite low, in fact, lower than 0. This is probably a negative number here. If I can have a negative number here, add 8, I could probably get to 2. But let's just, take it easy. We'll do the inverse signs, work backwards. 2, inverse of add 8 is take 8. 2 take 8. Now, we've been practicing this stuff. If you need to, use a number line, start at 2, move 8 steps back. Minus 6. 3 ends are equal to minus 6. Again, let's work backwards. Just because it's a negative does not stop us being able to do anything. We apply maths just the same. Negative 6. Opposite of times 3 is, or inverse, is divide 3. Now again, we've been practicing dividing and multiplying with negatives. So let's just think through the problem. 6 divide 3. That's always going to be what we do. 6 divide 3 is 2. Now we decide, is the answer negative or positive? Negative divided by positive. Oh, signs are different. Negative answer. And we got what we thought, actually. 3 lots of a negative number. Negative 6, cool. Negative 6 add 8 is 2. Awesome. We are applying two-step solving of linear equations with negative numbers. I'll give you one more. Again, this is the higher end of stuff, so if you're not quite there, we've got plenty of practice coming to us. Don't worry. Minus 2y, add 3 equals negative 11. Okay, really just want to separate those and make sure you know they're separate examples. So, let's go back through. Just because a negative doesn't mean it's not a problem, it's just a starting point. We're going to start at negative 11. And we're going to do the inverse of plus 3, which is take 3. So starting at negative 11 and move back 3 places. Totally doable. Use a number line if you need to. Negative 14. That's been undone. So we're still left with negative 2y equals negative 14. Again, we're going to just unpick this using inverse signs. That's minus 2 times y. Let's do divide by minus 2. To unpick that, so we're left with y equals, now again, we know we've been practicing this, 14 divide 7 will do. Forget the signs for now. 14 divide 2 My bad. 14 divided 2 is 7. Okay. Negative divide negative. All the signs are the same. So it's a positive 7. If you really want to, you can write positive 7. Totally unnecessary, though, when we got positive numbers. And that's how we do it. Cool, guys. Enjoy.